Hi, this video is to talk about hypothesis testing when we know the population standard deviation. Okay, this is one of the three cases are gonna have in this class. So the first one is hypothesis test about the mean when we know the population standard deviation. So what we're doing here is we don't know the population mean, and we're going to test if the population mean is higher, smaller, or different than a hypothesized number. And we'll use sample data, confidence level, and z-scores to come up with the hypothesis test. Okay, so let's have an understanding about hypothesis test. In hypothesis testing, we compare the value we hypothesize in the hypothesis with the value we found in a sample. Of course, take into account the variability in the sample. Okay, for example, we can say customers they purchase less than $50 per store visit. That's one of the claims we saw in one of the problems and claims that managers can make. They say, yeah, they buy less than $50. And then, okay, let's collect a sample of customers and see how much they spent. And then we collect, and then we get a mean of, let's say, 55. And then is more than 50. So we of course we have to take into account the variability, and this is what I'm going to show you. But the idea of having a hypothesis and collecting a data to compare. Okay, and then we get all this data and we transform into a z-score. That's the concept you learned in like chapter 6 or 7, I think. So, okay, so this is how you turn into z-score, but you're gonna use Excel, and you could use this formula and do by hand, but you have Excel to help you. Okay, so let's practice that. I can give you an idea about what this is. Hilltop Coffee. FTC wants to check Hilltop's claim that its large can of coffee contain 3 pounds of coffee. So this company says my coffee has at least 3 pounds or more of coffee. Okay. The FTC director wants to perform a hypothesis test with a 0.01 level of significance. Remember that's our alpha, to check the claim. Suppose a sample of 36 cans, so we have our sample size, provide a sample of 2.92. Previous studies show that the population standard deviation, this is very important keywords, population standard deviation. In this case, I know the population standard deviation can be assumed to be of this amount, and also that the population filling weight can be assumed to have a normal distribution. So what is the z-score in this case? Let me use here the resources I have, which is this. So let's start anew. Okay, so the null hypothesis is that it has suppose a random sample to its large can of contains 3 pounds of coffee. It doesn't say exactly if it is equal or has more and so on, but let's assume that it's equal or more than 3. The alternative is that it's less than 3. Okay, so we have all this information, and I turn so I have a mean. I have a sample mean. A sample mean is x bar. I have a sample mean equal to 2.92. You see it's smaller than 3, 2.92. And the population standard deviation is 0.18. And alpha is 0.01. We're not going to, and the sample size is 36. We're not going to use the alpha level now. Let's focus on working on the z-score. So this is a number. If I show this distribution, 2.92 would be below the mean of 3, right? Somewhere here. But I have to turn this 2.92 into a z-score. I standardize the score considering the standard deviation we have in the population. So how I standardize? We have here the tool to standardize. So I have the 2.92 minus the hypothesized mean. This is the hypothesized mean. Hypothesized mean is 3. 2 minus 3 divided by the standard deviation of the sample mean, which is in the denominator, which is 0.18 divided by the square root of 36. So this is equal to negative 0.08 divided by, let me use Excel very quickly just to compute the easy as a calculator. So I have 0.18 divided by the square root of 36. So that's 0.03, right? So let me go back here. So negative 0.08 divided by 0.03. Let me go back to Excel. So if I divide negative 0.08 by 0.03, I have negative 2.66. So that's my z-score, negative 2.67. Okay. So now I have a standardized distribution, the distribution of z-scores. So the mean is always 0 in standardized normal distribution. The mean is always 0. Remember the z-scores. So I know that this number, this z-score, let me change the color. This z-score here, let's wait, please show up on the screen. I don't know why it's taking too long. Okay, so this number is a negative number. I know that negative numbers are in this side. Okay, so it's negative 2.67. So in a distribution of z-scores, remember, one z-score up and below, this is negative, this is positive. I have 68.3% of all observations. 2 standard deviations or 2 z-scores, I have 95.4%. Remember that? This number is even smaller than negative 2, so it's a very small number. Because it's too small, it's a too small z-score, that our conclusion is that it comes from a different distribution. Okay, so it's very unlikely that this number, this negative 2.67 is from this distribution. It's not from this distribution. It's too small that our conclusion is that it comes from another distribution, which makes us conclude that the cans of coffee are not filling on average 3 pounds of coffee. They're filling less, okay? So this is how we work with the hypothesis test, okay? What is the z-score in this case? Negative 2.6. What is the z-score in the z-distribution? I showed you is very small, it's a very small z-score. So it's very unlikely that a normal distribution like this one will have a mean of with a z-score of negative 2.67. It has to come from a second distribution, an unknown distribution, and that's the reason we reject. This would be the distribution for the null hypothesis. This is the distribution for the alternative hypothesis. So we have to reject the null. It's too small to be from the null. Has to come from a second distribution, which is less than 3 pounds, or has to come from less than 3 pounds. Okay, the same thing here. I'm gonna leave you, I'm gonna ask you to read and try to come up with your own like practice. And I'm gonna stop here and show you the steps to start solving these problems in the next video.